Okay, so this type of factoring doesn't take long to teach, so it gives you a chance to do a lot of factoring practice and have a good long look at your exponent laws, because tomorrow's test is out of, I want to say 45, I think, and at least 20 of that 45 are exponent laws. And based on that quiz you just wrote, a great many of you are still having a great deal of problem with the 7 exponent laws. So you will want to have a look at that. So let us move on, though, because time cannot stand still. You will notice right there that I have 2 binomials that are extremely similar to each other, aren't they? The only thing that is different is the operation in the middle of the binomial. So when you are faced with that and you see an equals sign, the only thing that you can do is expand it, correct? Now, I know a great many of you are very good at expanding without writing it down the way I write it down. But if you are not one of those people, I cannot stress enough how important it is to just write stuff down. Then you can't get it wrong. Also, if you write this one out the way I write it out, you will see a very interesting pattern developing. So let's start. X times x is x squared. X times negative 4 is minus 4x. Then I'm going to go to the next term. 4 times x is positive 4x. And 4 times 4 is, of course, negative 16. And then you will notice something. X squared, what happens in this middle term? It disappears. Negative 4 plus 4 is gone. So I'm going to write something that we would never write. Plus 0x minus 16. Now, we would never write that, would we? But you will notice that that looks a great deal like the last couple of questions from your factoring the last day. You will notice that that 9 and that x squared stayed, but in the middle there was a 0. And when we factored it, we found 3 and negative 3. Down here, we noticed the x and the 25 stayed, but the middle term dropped out. Yes? So that takes us to where we are right now. This is really x squared minus 16, yes? Now, you should notice from the title of the section, difference of squares, and the fact that that is a square, and that is a square, and they are being subtracted, that this is indeed a difference of square numbers. Does everybody see that? Now, I will also remind you that if you saw a trinomial like this, you can always factor it by remembering, or you can try to factor it by remembering, I need numbers that multiply to negative 16 and add to 0. So it has to be 4 and negative 4. But of course, like many things in math, we get a pattern developing that we can use and exploit to our own benefit. When you come up to a binomial that has a square and a square, if both of those can be square root, then you can follow the pattern I'm about to show you, which is simply this. If I have any number squared minus any other number squared, if I factor it, I get the square root of the first number plus the square root of the second number. And then I get it again. The square root of the first number minus the square root of the second number. And please notice that is exactly what happened here. What is the square root of x squared? X, because x times x is x squared. What is the square root of 16? 4. So I did the square root of the first number, square root of a squared, which is a, square root of b squared. Since it was a 16, I put 4 there, right? Then I did the same thing with the minus sign. Now, we're going to do something a little weird here. I'm not going to start with number 1. And I'm going to start with number 2 instead. Now, notice that I have given you no examples that are exactly the same as the learning one, have I? Why do you think I have done that? Because the learning one is always the same. We should be at a point right now where once you see the learning one, you should be able to apply it to more complex ones. All right? So let's look at this very, very first, this very second one here. If there were no y squared there, is x squared a perfect square? Can I get a square root for it? Excellent. Is 225 a perfect square? Yes. What is the square root of 225? 15. Lovely. So if we were to follow the pattern the way I have written it right here, without the y, what would it be? What is the square root of x squared? X. What is the square root of 225? Plus 15. Then we write it again with the minus 15. Now I've left a blank space here. Why? Get it? I've left that blank space there for the y. What's the square root of y squared? Y. Y. And it's done. Is everybody with me? It is this easy. Now I want you to skip down to number 4. Is this a perfect square? Okay, so what is the square root of 4? 2. Now you have to know your exponent laws. What is the square root of x to the 6th? You're having a test on this tomorrow. Of the 30 of you, somebody should be able to tell me the square root of x to the 6th, considering you're having a test on it tomorrow. Yes, of course it is x cubed. Why? I'm looking for groups of 2, am I not? How many groups of 2 can I get out? 3 of them. So it's 2x cubed. So what do I write in the second set of brackets? 2x cubed. Excellent. Now, what is the square root of the second term? 5 what? Y. Excellent. Plus 5y minus 5y. Now those are the 2 easiest ones, except for the example one, right? All right, now let's look at 1 and 3. Does that have a square root? What is it? Please notice you just did the square root of x to the 6th, and it was x to the 3rd. So what must the square root of x to the 16th be? X to the 8. Excellent. So x to the 8 plus What's the square root of 1? 1. And then I write it again. X to the 8th minus 1. Am I done? Look at that, that, and that. Am I done? Carlin says no. Somebody else says yes. Why do you say what you say? Stop and think for a moment. Can anybody tell me, and I'm going to highlight one more thing and hopefully it will help you, if I am done or not? Does the green highlight thing look like the yellow, blue, and yellow highlight thing? What do you see in common between the green thing and the yellow, blue, yellow thing? I see a difference. I see a 1. And I see a first term with a similar exponent, yes? What is similar about 8 and 16? 8 plus 8 is 16, so 16 divided into 8 and 8, didn't it? Square rooted out to 8 and 8, yes? So will 8 break down to what? 4 and 4, yes? So I still have x to the 8th plus 1, because I can't do anything with a plus, and I'll show you why in a minute. But this is new. What is the first one? X to the 4th plus 1, and what's the second one? X to the 4th minus 1. Am I done? Carlin says no. Why am I not done? What do you notice there? It will break down again. To what? X squared plus 1, x squared minus 1. Am I done? Am I done? Am I done? 30 brains. Somebody can say yes or no. I know it. I'm not done. Jordan, why not? Because that's a squared minus a square, isn't it? So I have x to the 8th plus 1, x to the 4th plus 1, x to the 2 plus 1, x plus 1, x minus 1. Now am I done? Yes. Look at this one. Is that a perfect square? Yeah. How do you know? What about that term makes it a perfect square? As opposed to this, z to the 7th minus 144. Why is this one okay and this one not? The 8 is an even number, so I can take out groups of 2, can't I, Jasreet? So, what is the square root of z to the 8th? Z to the 4th. What is the square root of 144? 12. Then what do I write? Z to the fourth minus 12. Now, am I done? That's an even number. Is it a perfect square? Yes. That's minus. So is this a difference? Yes. Is 12 a perfect square? No. So am I done? I am indeed done. Is everybody cool? All right, now draw a line right there, because this is one of the easiest kinds of factoring, because all you got to do is take square roots. But it's got the most kind of tricks. Okay? Let's talk about a couple of them. First of all, let's talk about this one. I lie. Just an X, no 4. Does that, as it is now, look like a difference of squares? Is it a binomial? Yes. Is it a subtraction binomial? Yes. So we're halfway there, correct? But it doesn't look like it, does it? So what could I do there? What do you notice here and here? Same variable, so what can I do? No. I can do... What can I do?
GCF.
Great. So what would I try there? What is the common factor? So I'm going to divide by x. What do I get? X, 8x squared minus 1, yes? So I tried some factoring. Can I difference of square this? Look again. X squared is fine, 1 is fine, but does 8 have a square root? No. So I can't do anything. It looks like I can, but I can't. A great many of you try to force math into spaces where it cannot work. Is everybody cool with that? All right, now I'm going to change this one slightly. I'm going to keep working with this one. What if I changed it to 8x cubed minus 8x? Now what would I do? I would GCF again, and what is it? 8x, so I'd have 8x, x squared minus 1. Now can I factor again? Is that a square? Is 1 a square? So I would factor that to 8x, x plus 1, x minus 1. Cool? Yeah. All right. Now you've already seen this one when it's got numbers, right? This one had numbers, so we GCF'd out. Okay. What if I gave you this? Is that factorable? I've given you a trick to doing these. What are you allowed to do when you see something like that? Pardon me? I can rewrite it as what, Jordan? Am I allowed to do something like this? A equals x minus 2. What does this mean? That means everywhere I see x minus 2, what can I write? A. So this becomes a squared minus 9. Does everybody see? Does this look exactly like this? So how would I factor that? What's the square root of a squared? A. What's the square root of 9? Minus 3. Then what do I write? A plus 3. What's a? X minus 2. What letter is that? A. So what do I write there? X minus 2. X minus 2 minus 3. What's that? X minus 2 minus 3. X minus 5. And what's that? X minus 2 plus 3. What's that? X plus 1. There's nothing fancy about it. Everybody good? Okay. Now, about the hardest one of these I can give you would be this, and I'm going to write it in green. Now, on this page, you have all the tools you need to solve that. See if you can. Talk to your neighbor if you need to. Would anybody like to say what they tried first? Could you rewrite this? As what? What can I do with that and that to make it look prettier? I can change it, can't I? Can I use the same letter, Jordan? No, why not? because they're two different binomials. So I would need to write, I'm going to make him A and him B. Is that cool? So I get 16A squared minus 25B squared, don't I? What's the square root of that first one? 4A. Plus, what's the square root of that second one? 5B. Then what do I write? Same thing, except 4A minus 5B. Now, what's A? X minus 4. So this is 4x minus 4, isn't it? Plus 5. What's B? Y plus 2. What's 4 times x minus 4? 4x minus 16 plus, what's this one? 5y plus 10. Can I put x's and y's together? No. So it's 4x plus 5y. Can I do negative 16 plus 10? What's that? Negative 6. Now let's come over to this side. 4 times 4x minus 4. Or not 4x minus 4, you idiot. And please remember, guys, this is about the hardest question I can give you. So if you're a little lost over here, that's no big deal. Minus 5 times y plus 2, yes? So that is 4x minus 16 again, minus 5y minus 10. Can I put x's and y's together? No, so it's 4x minus 5y. And what's negative 16 minus 10 now? Negative 26. Now, like I say, that's about the hardest I can go. What do you notice, though? When you do this to this step, it's so much easier, isn't it? Are you allowed to do that anytime you want? Yeah, you are. Okay? Now listen to me. Because I am not giving you your test today, things are a little weird right now. It made perfect sense to give you a test today, let you finish yesterday's practice after the test, and move on tomorrow. But, as is evidenced by the fact that there is a lot of issues with multiplying and exponents, I didn't give you that test. So here's what's going to happen. Right now, you already have page 131 to 132. That was already assigned to you. I was expecting that to be done for tomorrow, right? Because you were going to finish your test today, work on it today, and do it tonight, right? So now, what I'm going to say is I want 131 to 132 and page 134 done for Thursday. Because tomorrow you're going to write your test. Okay? So I'm going to go up to the big board. I'm going to change everything here to be pages 131 to 32, page 134 for Thursday, and your Unit 3 test is now Wednesday. Please notice there is no approximately anymore. You are writing this test tomorrow. Do I make myself clear? Now, why am I doing that? Because I don't believe you're ready for it. The reason I don't believe you're ready for it is my most recent evidence of asking you your exponent laws did not go well for a great many of you. Which means, right now, since I'm done talking, it's time for you to start working. A great many of you are not going to work. Again, that is fine. But be aware that you are being assessed on something in math class tomorrow. You are not being assessed on sitting with your buddies and talking about what you did last night, the night before, or what you plan to do tonight, tomorrow night, or next weekend. Okay? If you choose to use your time unwisely, that is fine, but be warned again, you will get the results back that depend on the results you put in. Okay? If you are all right with not achieving passing grades, then by all means continue the way you have been going. Okay? Because you're in grade 10 now, and I should not have to hold your hand. Go. I will be